Okay, waste heat is required. We know that waste heat is required, and that leads us to a statement of the second law that is very famous. It's called the Kelvin-Planck statement. Okay, this is the only thing in this class that you're going to need to really like know. Well, not the only thing you need to know, that you need to kind of understand. That's not a calculation. This is, if I ask you to restate the Kelvin-Planck statement, I'm going to want you to put this in your own words, and I'll provide you what those words could be. Okay, so here's the official statement. It said it is impossible for any device that operates on a cycle. That's the main thing. Operates on a cycle to receive heat from a single reservoir and produce a net amount of work. Okay, this is saying there must be waste heat. Okay, you cannot have a situation like this where you have your hot reservoir and you have your cycle, and maybe you're putting in here 100 kilojoules and you're going to get out 100 kilojoules. This is not possible. You cannot have an efficiency that is what do you want over what do you have to give that's equal to 1 or 100%. Okay, this has nothing to do with the friction. I've asked this question many times on exams. Why cannot the efficiency of a power cycle be 100%? And they'll say, oh, because of friction or because of deformation inside of stuff. No, it's not have anything to do with that. It has to do with the fact of the second law that you must have waste heat. We have to let a little bit of that heat go. Okay, and so we can never reach 100%. The reason why we cannot reach 100% is because of thermodynamics, not because of friction. Okay, now the question may be asked about, okay, now what do we do about, we talk about power cycles, what are we going to say about heat pumps or refrigeration cycles? And there is a similar statement that works with this, and it's called the Clausius statement of the second law. So let's talk about the Clausius statement. This is the other thing you need to know. The Clausius statement of the second law says it is impossible to construct a device that operates in a cycle and produces no effect other than transfer of heat. Oh, there you go, my computer. My computer is now transferring some heat there. Transfer heat from a lower temperature to a higher temperature body. Okay, it is impossible. And it's also saying about a cycle. Okay, it's very important. It's impossible to construct a device that operates in a cycle that produces no effect other than the transfer of heat from a lower temperature to a higher temperature body. We can't do that. We can't transfer in a cycle heat from a lower temperature to a higher temperature body. We do it in a refrigeration cycle, and what do we need to do? We need to plug it in. So it has to be this. There's going to be another effect. It needs to be some power into it. There needs to be some work into it to do that. Okay. So Clausius statement, second law, saying that you got to plug in your refrigerator for it to work. Kelvin Planck statement saying you got to. Thermodynamics is the reason why you can't have 100% efficiency, because you must have waste heat. Okay. So we need to understand these two laws, and we're going to start with them and build upon those. On Friday's lecture, we're going to now start talking about some ideas that will lead us into some calculations that we can make. So there's no homework for today. There's no homework today. I just want us to introduce the ideas, talk about these ideas. Now, I want to end with one thing, and I want to talk about the exam that you took on Monday night. It is my philosophy in this class and in my time teaching that I want to see how you think. And seeing how you think is not an easy process. If I were to give you exam problems that were exactly the same as your homework, or it was something that you had memorized, that's not how you're thinking. That's what you could, as fast as possible, put into your brain, and that isn't retained as long. When I give the exams that I give, I try to put some problems in there that'll stretch you a little bit. I do it on purpose. I try to put you in situations you may not have seen before, but you have the tools to do. And I can argue everything on that exam. You have the tools to do. But some of you walked out of there feeling okay. Some of you walked out of there feeling pretty bad. And this is not a unique thing to this semester. This is what's happened through my time here at K-State. And I keep giving the same type of exam because I learned so much about what you know. And I will grade appropriately. I try not to give a lot of exceptional amount of points to the final answers. I like to see the process. I like to say if you know the process for every problem, you can't get below a C. And that's what I like to try to say. Now, we can argue if that doesn't happen for you or not, but that's what I try to do. So I got a lot of emails, and I just want to say, let's wait. Let's wait until I grade it, and then we'll talk about some things. We'll talk about where we are, where we need to be, where you want to be, how we can get there, and how that all is going to work out through thermo. And I'm not going to try to tank your grade. In fact, I've been accused of giving too many A's. And they're not given, they're earned. And so I make that argument about there. We can get there. We can get there. We can work together and get there. Let's wait. These exams will be graded probably Monday or Tuesday of next week, and then we can have that conversation. But that's the job for the evenings and the weekends for me, and I'll see you in this video lecture on Friday. Until then, have a good rest of your week.